Hi, I'm Sanjay Nagchaudhary, Development Lead for the IBM App Connect Enterprise product. In this video, I will describe how to reference locations in the context tree using the context reference ESQL function from compute nodes which are in nested subflows. So in the previous videos, I introduced the context tree and gave an example of how to access payload data from earlier nodes in the message flow. The context tree is a new tree in the message assembly, which is not captured by default. It is only made available in the message assembly when it is referenced. In the ESQL example that I used in the last video, I showed how to use the context reference and context invocation node ESQL functions. You can see the example on this slide. In this video, I'm going to show a message flow which has several nested subflows. In each subflow, there is a compute node which has not been named very well. It has the original compute name as the node label. It is strongly advised that nodes are named appropriately and use unique names if possible. But in this case, there are several compute nodes with the same name across different nested subflows. The context reference function can cope with nodes that have the same node labels in the flow hierarchy by allowing the use of a level name parameter keyword, which I will now demonstrate. So this is the message flow that I used in the last video. I have a main message flow which has two HTTP input nodes. They each receive a JSON message. There are two REST request nodes that each make a request to a different REST API. Both REST APIs are deployed to the same integration server. REST operation simply takes some input data as a query parameter and it is converted to uppercase and returned. The two REST APIs have been imported from a tutorial called Aggregation Nodes using REST Async Request Nodes with Backend Services. You can import that tutorial by opening the tutorials gallery, and if you search for REST, you can see the tutorial and you can then import the projects from that tutorial. I have a subflow. It is called by a subflow node, and in the subflow there is a compute node, and the compute node can create a response that is sent back by the flow. The response is constructed by using data from the input node. This is reached by using the context invocation node. It also uses data that is returned from each REST API. So the output from the first REST request node is used and is set in the response. And the output from the second REST request node is also used and it is also set in the response. So this was a message flow that had a single subflow and that returned a response. I'm going to show you a similar message flow now, which does a similar thing, but it is split across many nested subflows. So this is the top level main flow. Again, there are two input nodes and there are two REST request nodes, and there is a subflow node which is calling a subflow. When I drill down, this is calling a subflow called use context input. And in there is a compute node and it is getting the payload from the input message and it is setting it in the output from the compute node and it is calling it input data. So it's referring to the input data that was received by the original message flow. So this subflow then calls another subflow, and if I drill down into that subflow, we can see there's another compute node. It's called compute again. And in this compute node, I am extracting the payload from the first REST request node. So that is called get backend 1. And I am setting it in the output of this compute node and I'm setting it in an element called backend 1 data. So then After that, it calls another subflow. So I'm going to drill down into that subflow. And this has a compute node as well. Again, it's called compute. And in this compute node, it is getting the payload from the second REST request node, which was in the top level message flow. And it is assigning an element called backend2 data to the output from that second REST request node. And then it also has a subflow node, and this calls the final subflow. And again, this is called compute. And inside this compute node, I'm constructing the overall response. Now, in order to do this, I need to get the output from 3 earlier compute nodes. And they're all called compute. Now, the way to distinguish them is to use this parameter keyword called level name. And in here, I'm specifying the name of a subflow node. So the subflow node is called use context input in this subflow. And then I am getting the output of the next compute node in the next subflow. And that is using a subflow node called use context for backend 1. And then finally, I'm getting the output from the third compute node. And that is referenced by a subflow node called use context for backend 2. So by declaring those 3 variables, I am then setting up the response and sending it back. So they are badly named compute nodes. Really, we encourage to use node names which are appropriately named, preferably unique. But if you do have flows which have the same name, then they can be distinguished. That is the compute node in the use context input subflow. This is the compute node in the use context for backend 1 subflow. And this is the compute node in the use context for backend 2 subflow. And then I'm constructing the response in this very bottom subflow called construct response. And here it is constructing the response. Okay, so let's try sending a message through. I'll use the flow exerciser. I'll send a message. So I'm sending in the name Ben. And I'll click send. But I can see the input message was sent and I can see the response back. So the response was constructed from the input message and the payload from each REST request node. So in the main flow, I can see the context tree. I can see the nodes here before the subflow node. If I drill down into the subflow, if I click on the message assembly after the compute node, then you can see that it constructs an output called input data and has Ben next to it. If I drill down to the next one, we can see the next compute node creates output called backend 1 data. Drill down again and look at the message assembly after this compute node. We can see this has backend 2 data. And if we go down to the final compute node, we can see that the complete response is created here. And if we go back to the final message flow and look at the message assembly after the subflow node, we can see that the response is constructed and we can see the nodes. So that was all done by using the context reference function, and we used level name to distinguish between the different levels in the call hierarchy. So in this video, I've demonstrated how to use the context reference ESQL function with the level name parameter keyword to overcome situations where there are nodes which have the same node labels in the flow hierarchy.